let's just quickly go over what we're going to do today and what we're going to take a look at, and that'll sort of set the tone for what you could expect from today's session. The goal for today here is I want to make it. There's a lot of confusion around AI agents, and how to build them and that sort of thing. And hopefully, the goal for today is that you'll walk away with a better understanding of agents and potentially um, just like a first taste of how to create agents without really needing to be able to code. That's the idea. And along with this session, and this is the first time that I'm actually doing a live demo of an app that I put together for this demo. But the idea here is that I'll polish it up a little bit more, and maybe over the next week or so, and maybe release it next weekend. So that's the idea, so that you could all have access to this and download it and play it, use it on your own computers. Okay, it's going to be open source, so please keep an eye out for AxeChat. All right, so let's get started. So the goal for today, well, basically, we want to make it. Want to demo that it's not necessary to write massive prompts or be an expert at prompting to use LLMs. And the other goal is we want to show you that even if you don't really know how to code, you could create very complex agentic behaviors. And for now, let's get into the details later. But for now, I want to sort of put that up in front in your minds about what we're hoping to achieve here. And I'd love some feedback towards the end as well. So let's quickly just go over some concepts because there are different definitions for things these days. So what's an agent? Basically, an agent is a piece of software that uses a large language model. So, for example, you've obviously heard of OpenAI. OpenAI has a number of models. So does Google, Anthropic, and a lot of other model providers. Those large language models are used by an agent to achieve a task. What else does an agent have access to? Typically, they've got access to tools, or you know, if you've heard of more MCP servers, those are tools that an agent can use to achieve their task. And sometimes agents also have memory and access to other resources. But at a high level, agents have access to an LLM tools and some memory. Okay. And then we'll be also discussing crews of agents. And so you'll notice quickly here on this agent sidebar, we've got agent crews. So agent crews are just a collection of agents that come together to be able to perform a task. So think of this as a team. You've got an engineering team, a finance team in a company, marketing, sales, and so on. So crews are similar. They're a team, and they can collaborate with each other to perform to obtain a certain outcome or perform a task. So I think that's enough of talking for now. Let's just go straight into the demo, and then we'll deep dive a little bit more into what creates a crew, how do you actually write a crew, and so on. Okay. So here, what I've got, as I said before, this piece of software. We are going to open source it, and uh, and so we've tried to make it really, really simple and easy to use. The only prerequisites to use it are API keys. So every large language model provider typically lets you connect to their LLM API services using API keys. So you might have to go and sign up for an API key. For example, to get an API key for Gemini, which is a Google model, you would typically go to aistudio.google.com, get an API key, and they'll you can create API keys here. Similarly, with OpenAI and Anthropic, they've got a similar process. Um, a lot of these model providers have sort of free tiers that you can just use. So you may not need to pay initially for the usage, but after you've hit your free tier limit, you would have to put in a credit card at some point. So once you've got those API keys, don't worry about this one. I'll come back to it later. Once you've got those API keys, you would put them in here, and then you should be able to create your first crew. So I'm just going to create a new crew and give it a name. So it's like let's call it a math geek and solves hard math problems. And the crew configuration, so don't worry about this, I'll get into this later. So I've just created a math geek crew. Now you've got the option to select crews, so I'm just going to go back to the one that I had before, and you can chat with this crew. So you'll notice that there are there's a planning a manager there's a planner crew, there's a manager crew, there's a math agent, maps agent, Google search, and Airbnb. Why did I put Airbnb there? It was just because someone was doing this demo the other day about how they planned their trip with an Airbnb agent. So I just wanted to recreate that. So that's why it's there. But what I wanted to really stress upon here is you don't really need so many agents in a crew. The only one that you really would need is the manager. Um, okay, someone just reminded me that I need to record this stream. Second, see if I can. Oh, okay, it's probably already on. So the manager is the only crew that you only agent in the crew that you really need, and the others are there to sort of assist the manager. So you can think of the manager as a sort of like a top level, like the boss of the crew, right? And then the other ones are just it uses the other agents to perform tasks. So let's see how the manager would use this math agent to do something. So I'm going to ask a question here. Who is considered as the father of the iPhone, and what is the seventh root of the year of birth of this person? So, who is considered the father of the iPhone? That's a pretty easy to answer question, right? Because it's already out there. Most people think it's Steve Jobs. Some people say it's someone else. But anyway, um, it's an answer that is available in the LLM's training data. So obviously it knows who that person is. What about the seventh root of the year of birth of this person? Now that's definitely not in its training data. So hopefully when we fire off this query, what's going to happen is that it's going to engage this math agent to calculate that. Okay, if we're to get a response, let's quickly check that. This is why I didn't want to release the code right away, because I need to test it more. I'm just going to reset everything. So bear with me one second. This is, uh, I've been told lots of times by people that you need to sacrifice to the demo gods before doing live demos, which obviously I haven't done. So bear with me one second while I just reset my system. Okay, and just to be sure, I'm going to add in my environment variables again. Okay, that should be in there. All right, so that's running now, and I'm just going to pull this down. So you'll notice that the agent's doing something in the background. It's done a Google search, and the Google search result says Steve Jobs is considered as the father of the iPhone. And then at some point, it should engage. Yes, so it's engaged the math agent, and the math agent has come back with a solution. And that's a pretty, it's a pretty long number. That's not a hallucinated number, by the way. So if you take let's take this number, and if you want to confirm that it's actually performed the calculation, x to the power of y 7 1955. See, that's not actually a hallucination. So how does this work? We'll get into the details of how that actually works in a second. Okay, so we've just done a quick demo of this math agent. Let's look at what the maps agent can do. So let's say I was to plan a trip to Sydney. I would probably be looking for Airbnbs somewhere close to the city. So I can say, can you find a nice Airbnb for me with maybe a nice view uh, in the Sydney CBD area. Hmm. Okay, so okay, let me see if I can zoom in here like this because I got feedback that the demo needs to be bigger. Okay, let's see. Nice. Okay. So Woolloomooloo is definitely a nice area in Sydney. It's usually got a waterfront view of of the Sydney Harbour. So yeah, perfect. So that's working fine. How does that work? Again, we'll get into details a bit more, but a bit later. But hang on. Make this much bigger. Hopefully, this is a bigger screen. Hopefully, it's a bigger screen to look at. Um, and I've zoomed in a bit. Okay, so we've had a look at the math agent, the maps agent, Google. Let's try a Google search as well. So hmm, uh, let's say what's happening in the field of quantum uh, quantum computers. What's the latest news in this area? So I'm going to guess that it's going to engage Google search because when we say latest, it's there's something in the latent space of the model that's of the manager model that is going to trigger a search for Google for something on Google, and you can see that it's engaged the Google search agent. By the way, something that we're keen to do as well is sort of give you feedback on what it's doing. So while it's actually thinking, we might sort of push some feedback here on the screen to let you know that it's doing this. Just small improvements to improve the UX at some point. But it's done a Google search and it's come back with some interesting observations. So one of our clients actually uses this agent to write content for their blogs. So for example, think about let's say the latest industry research in a particular sector, maybe drone technology, for example. You do need a lot of deep search style capabilities. So what you can do with Google searches, you can really set how many searches you want to perform. 5, 10, 15, 20, 100 searches, etc. And then break that down into core concepts, bring all the concepts together, and produce content in whatever style, interesting, funny, engaging, scientific, and so on. All right, so that was the Google search. We've looked at Airbnb already. um, Maps agent, actually what happened was we would have probably triggered the Airbnb agent when looking at yes, when looking at these listings. And you can use a maps agent in a very similar fashion. For example, nice Spanish restaurants in the Sydney CBD. Now it's engaged the maps agent and it's going to do a Google Maps search and kind of compile some results from there. So the stars and that sort of thing. So obviously you can put all of this together, all of these things together, and say, just plan a trip for me. I will have 2 nights free in Sydney. Recommend dinner spots and things to well play, yeah, attractions. And then what's going to happen is that you'll have that will engage the manager will then go ahead and work out all of the other agents that it has access to, and then create a plan for how to tackle this task. And then it will start asking questions of these agents. So hey, can you search for interesting things to do in Sydney, search for good restaurants, search for an Airbnb to live in, and so on. So I'm sure you've seen many of these demos in the past, but the thing here is that all of these tools, they you don't really need um, an engineer to sort of create these tools like from scratch if you know a little bit of coding. And hopefully in the future we will eliminate code altogether. Okay, so when I say a little bit of coding, I want to quickly talk about what that means. Let's jump into the script planner agent that we discussed, and you'll notice there's a crew configuration. I'm going to pull that up here. So now we're going to go into the structure of this crew and how it was built. By the way, none of this would have been possible without a great little framework. I think it's actually the best framework out there for developing agents. It's called AxeLLM. So I'll post this reference document later on. Not really sure if I can do that here, but I'm going to make it available on LinkedIn so that you can access it and look at all of these references. But it's mentioned in there, so not to worry. This framework then allowed me to create something called as the Axe Crew framework, which is what we're taking a look at. So a crew is just a combination of agents, and you can build all of these very complex and very complex agents if you wanted to using the Axe framework. Okay, so let's quickly jump into the code, and I'm going to open up a new code window. All right, so here is, hang on one second. Okay, so this is what the crew looks like. I'm just going to hide all of these parts to begin with so it doesn't scare you. And let's break it down. Okay, now you might notice that you might have heard of prompting quite a bit, right? But if you'll notice that there's minimal prompting involved in setting up a crew. So you don't have to be a really skilled prompt engineer or anything like that to write very complex AI agents. Now, I said before that the manager agent is the only one that you really need to get this crew going. You don't really need any of the other ones. So let's talk about the manager agent first. Um, so the manager basically has a name, it has a description, it has something called as a signature, and then it needs to use LLM. So we've got some information here that tells that agent what LLM to use, um, and some options. So these are very well documented, but you can always ask me on LinkedIn or over email how to do something. I'll be happy to help you. It needs access to tools. So current, it has access to a couple of them. What the date and time is today, and how much, what's like a function just to calculate the difference between dates, because sometimes that's useful. But you don't really need any of this. All you need is you need a name for the agent. You need a description, and the description tells the LLM what this agent is supposed to do. So here I've got a description: engage with the user on their task, question, or comment. That's it. You know, so it's very open ended. For very specific tasks, you might have a different description, as we'll see for other agents later on. Then you've got this magical signature pattern. So we're going to refactor the signature so it doesn't look like that. It'll look a little bit more cleaner when we release this code. So, but for now, let me just break it down for you. The signature is made up of two parts. There's input, then there's this arrow here, and then you've got output. Okay, so input, arrow, output. And input is basically everything that you will send to the agent, and then output is everything you want it to send back to you. So here I'm saying I'm going to input a plan to you. So where does this plan come from? It actually comes from a different agent. So we've got a planner agent here that creates a plan. It's got access to, as its input, it's got access to some chat history, and the task for this agent is just to create a plan. That's it, nothing else. It doesn't do anything else. It just creates a plan, and so that plan is then an input to this agent, and that's all just defined right there. You don't have to do any more, code, uh, coding or anything like that, because our app kind of takes care of that. It takes care of how these agents talk to each other. And then you've got basically the LLM details. So you've got a provider, that's Anthropic. This is the API keys that we set up and in settings. So we've got Anthropic API key there, and then the model that we're going to use. Um, okay, and then this manager. Remember how I said this manager is the boss of the other agents. So this manager has access to other agents as well. It's got access to the math agent, a maps agent, Google search, and Airbnb agent. Okay, so now let's look at the implementation of those agents. So a math agent, now the description changes. It says solve math problems, and the input is just a string. So it's just a piece of text. It's a sentence describing a math problem to be solved using Python code. Now, who creates this sentence? Who creates this input? Once you're past the manager agent, all of these inputs are created by the AI. They're not actually handwritten. So I don't have to sit there and say, okay, here is the exact math problem that I want you to solve. No. So the manager agent takes a task from me. Okay, so this is a question from the user, and then rewrites that task if it needs to engage the math agent. It has the intelligence to engage a math agent when needed, and then it rewrites the task and describes the problem internally. So you don't even have to think about it. Okay. Uh, Similarly, so let me show you a Google search agent here. Okay. Again, Google search. It's got as input Google search query, keywords or topics to search for, and then it outputs Google search results. Now, the query again is written by the manager. It's not written by us, not written by the human. The Airbnb agent is a little bit, it's slightly interesting. It's so the description is search Airbnb for listings based on the user's request. You've got to input, the manager will input a location name and a check-in date and a checkout date in a certain format. And then the output is a list of search results. Okay. But it's got something a little bit different from the other agents, and that is this section here called MCP servers. So MCP servers are sort of like a new, well, it's not new. It's about 6 months old as a concept, but they've really, taken off on social media recently, especially on Twitter. MCP servers are reusable tools for AI. So if I write an MCP server, and someone has written this MCP server called Airbnb, it's an Airbnb MCP server, they can then publish it. So they've published it here on, I think this is on GitHub, or sorry, not GitHub, it's on NPM or something like that. So they publish. It doesn't matter where it is, right? They published it somewhere, and if you know how to pull the code and run it locally, you can then simply write this bit of code into your agent, and all of a sudden it's got access to search Airbnb. Right? That's what makes it so powerful, because it's reusable. Okay. So then what happens now is that you've defined these agents. The manager agent needs to know about them. So how do you tell the manager agent that they exist? It's really simple. You create an array of agents that it has access to. So this is just a list of agents. You provide it to the manager agent in this format, and really that is it. You There is no other code required to be able to code these agents. So again, like I said before, you don't really need the planner. You don't need separate agents to do these things. You can, for the sake of quality of results and things like that, you can separate these agents. But really, what I could have done is I could have just uh, taken the manager agent and added an MCP server to it, and now the manager has direct access um, to search Airbnb. It no longer needs the Airbnb agent. So so you could, in theory, get rid of all of this. So you've got one giant manager agent, and the goal of this agent then would be to use whatever to. Oh, actually, it would error out now because we've deleted the other agents. So you would no longer need this. So now it only has access to the Airbnb tool, but it can still perform reasonably complex tasks. It'll probably error out now when it tries to calculate, the seventh root of 1955. It won't be able to answer that question because you've taken away the math agent functionality. But let me quickly show you also the math agent. It's interesting. Undo, undo, undo. Maps, math agent. Okay. So it looks pretty basic, right? Math agent solves maths problems. It's got an input and a solution as the output. What makes this a math agent is actually a combination of using this particular model from Google, Gemini 1.5 Pro. Now they've got 2.5 Pro, so you could use 2.5 Pro instead of 1.5 Pro. And another optional feature of the AXLLM framework, it's called code execution. And you enable code execution to be true, which basically says that tells the model that you can write code, run the code, and give me the result. And that is super powerful because now you can do very, very complex things. Imagine looking at a spreadsheet and uploading a spreadsheet into the chat interface and then asking the manager agent to uh, do a lot of analysis that would have taken you maybe a whole day to do. You know, so so this math agent is very powerful from that perspective. All right, I'll be available on LinkedIn, and you can just ping me there and ask questions there, and maybe I'll see you I'm hoping to do this every Friday around the same time every Friday. So maybe I'll be able to do like a live session with a lot of different speakers as well. All right. So let's end the session for today, and we'll talk soon. Talk on LinkedIn or wherever. I'll also post the resources on LinkedIn, so you'll have those handy if you go to my LinkedIn profile a bit later today. All right. Thank you. Bye.